Welcome back. In this video, I want to talk to you about some useful functions that we get that actually allow us to think in a functional programming paradigm. The name of these functions are map, filter, zip, and reduce. These are very useful functions that will write a lot. So let's explore them. First one, we're going to start with map. Map actually allows us to simplify this multiply by 2 function that we have here. This is a function that we have already written in the previous video. So let's see how map can do that. Let's write map, and if you see the information given here, it says as arguments it takes a function and it takes a iterable. So what it's saying is, it says it takes a function and it takes a iterable. Now one way to think about this is, it's saying it's asking for an action and it's asking for data to perform the action on. So we give it action, which is a function, in our case which is multiply by 2, and then we give it the data that we want the action to be performed on. So what we can do is, our function in this case is multiply by 2, and our iterable is a list of 1, 2, 3. Now we'll just move this down. I'll just copy it and move this down because we have to define the function first. And if I run this, nothing happens because we haven't printed this. So let's remove it and put the print here. And if I run it now, you see it says map object at this. So it's saying is, the map has created an object for us at this location. Now the way we want to view this is, we have to convert this object to a list. So we just say list and we put it all in these brackets and then we run it. So it says at line 4 in multiply by 2, int object is not iterable. So with map, we actually don't need to define this new list, and we actually don't need to add it to a new list. We don't need any of it, because what map is asking for us is to give it an action that we want to perform on an iterable. So what we can do is, we can just remove it all and we can say return item multiply by 2. So map is just asking for an action, and this is the action. Map is not asking for a new list and to append to a new list. It's just asking for an action. Our action in this case is multiplying each of the elements in this list by 2. So we give this action in the return statement, and our iterable is this, and we give this iterable to the parameters of this function. So if I run this now, it gives us 246, which is the correct answer. Now let's say, instead of the list, we define a new list, and the new list is 1, 2, 3, and then we replace this by new list. If I run this now, it gives us the same answer. But has it modified the new list? Let's check out. Print new list, and when we do that, the new list hasn't changed. So the new list is out of the world of this function. It belongs to the outside world, and the map function hasn't modified it. It has performed the function, but it hasn't modified the list. So what we can say is, map function also helps us to keep the function pure. And that's what we studied in the pure functions. We studied that we have to keep the pure function, we have to keep the functions pure so that we have less errors, and map helps in that. Map helps us to keep our code clean. It helps to simplify the whole code, and it also keeps the functions pure. So that is map function, and this was the power of map functions. Now let's talk about filters. So from the name, you must have guessed what it does. It filters things for us. So with map, we always got the same number of items back, right? We have 3 items and we got 3 items back. We just mapped over each item and it returned us all of the items by multiplying it by 2. With filter, we can sometimes receive less than what we gave. We are filtering some of our results. So let's create a function. I'm going to define a function here and define only or. Inside we give it an item. So what we want this function to do is, we want this function to take a list of items and from that list return only the odd elements in that list. So the way we can do this is we can say return, just like we gave the return statement in this above function, we're going to give the return statement here and we say item modulo 2 is not equal to 0. So let's say our item is 1 and or let's say our item is some odd number and odd number modulo 2 will never give the answer or will never give the remainder 0, so it will return true. Now what filter wants is, filter takes a boolean expression, true or false statement, and if the statement is true it returns that output and if it's false it filters it out. So let's write our filter function and we're just going to remove this. So again we say list and we give it the filter function and inside filter function we give it this only odd function and for the iterable we give it this new list. And let's not forget to put the bracket here. Now if I run it, you see it gives us 1,3. So what it does is, it takes this new list which is again a list of 1 2 3, it iterates over it. So first it gives 1 to this item, now 1 goes here to perform an action on it and 1 modulo 2 will never give a remainder of 0, so this statement is true. Therefore since it's true, the filter returns it. In the second case, when it iterates over 2 and it gets 2 and it gives this 2 to this item, 2 modulo 2 is equal to 0. So this statement of not equal to 0 becomes false. Therefore, it filters it out and doesn't return it. So this is the filter function, and you see again this filter function doesn't change this new list, doesn't interfere with this outside of the world function. So it also helps to keep the functions pure, and again both map and filter help us keep our code clean and keep the functions pure. Now for example, let's say we have a list of a lot of students and we want to filter it out based on the names that start with A. So what we can do is we can again create a filter function and filter all the ones which have the name not starting with A out. So we get a list of students with the name A. So these filter and map functions are really useful in those cases. Everything is just nice and simple.